How does AI think life began? And does it think that life was inevitable? Let's find out. Hey y'all, what's up? If you're new here, my name is Reese. I used to teach tech ethics at MIT, but now I'm just an information sponge. And so for the past decade or so, I've done hundreds of interviews and read hundreds of books around the language of life. And I've put all of those into this note card system where I've made 20,000 note cards, and I study that to have a little bit of fluency in the language of reality. And I want to share that fluency with you all in this series called How Everything Evolved, where we go from the Big Bang through AI. And so right now we're looking at life and trying to understand life. In order to understand life, obviously I've been using AI as a tutor, essentially using AI as a tutor. And so I want to share with you some of how I use AI, okay? And so we can look at, here's O3. And so in general, by the way, obviously you're trying to use, you can use 4.0 for quicker things, but if you want actual answers, you're trying to use O3. Or you can use, Claude in its thinking mode, or Gemini in its thinking mode, or, DeepSeek or whatever, kind of doesn't matter. And so I want to share with you me chatting with O3 recently about the origin of life. And so you can see here at the top, I say, evaluate the different theories of the origin of life, RNA World, Eric Smith's RTCA cycle, Bruce Damer's hot springs hypothesis, etc. Give percent chances for the likelihood of each. Take it seriously, evaluating as a polymathic scientist. So you're giving it a little bit of context around the existing things to look at. Give it the percent chances of the likelihood of each. I don't want to just say, here's this theory, here's this theory. I think quantification is very kind of helpful just to make sure you understand that if it's like, hey, there's a 75% chance that everybody believes the hot springs theory, that's great to know. And so I think getting to that quantification is really nice. And so here goes, it's thought for a minute and 21 seconds. And it gives these rough overview, And you can see here that there's this, alkaline vent metabolism first, Nick Lane's book. And then, that's like 25%. So that's kind of the classic deep sea vents theory. Then there's kind of the classic RNA World theory, where you say, okay, we have these RNA things kind of catalyzing their own replication. And that says 20%. And then they say, okay, this hybrid metabolism to RNA ladder, where you're taking something like the first one and you're combining with something like the second one, but you're instead of focusing on the vents, you're focusing on that, reverse TCA cycle. And they say, okay, maybe it's 20% for that. And then this wet dry cycling with hot springs, they say is like 15%. So that's kind of interesting. So you get an overall view that's like, it's probably one of these top four, It's unlikely to be panspermia. It's unlikely to be some random other thing, these weird ice theories or what have you. It's unlikely to be these old lipid world theories or whatever. So that's kind of helpful, I think, to understand it at the front. And then I said, that's okay. But then I said, hey, there's this great John Sutherland piece on sanosulfidic and carbon carboxyl sulfidic chemistry. And I just copy pasted a transcript, a recent talk he gave on these other cycles. Because I'm like, yeah, these other cycles and, hydrogen cyanide is pretty tempting and it's not really talked about up here. And so then it thinks again, it says, hey, I'm excited by it, but not that excited. And then I say, hey, could you update your percentage chances given these Sutherland theories? Because I was like, these seem kind of tempting to me. And so what it roughly does is it's funny is it says, okay, now I'm going to give this new thing 27% likelihood, which is, I'm like, okay, I like that. I was kind of tempted by this theory. And it took away a little bit from, I guess the key thing that it did is it took this like Eric Smith thing and it said, hey, no, that these are, instead, we're just going to combine that into this top one up here. So I don't know. It's kind of an interesting thing to say, okay, I don't know, does it have like recency bias or whatever with this? And I say that, I'm like, it's weird that you didn't even give this theory any weight at the beginning, but now give it 27%. It's like, oh yeah, blah, blah, blah. All things considered, HCN is not just another starting molecule. It's the keystone of his system. So I'm like, oh, it's weird that you didn't give this theory any weight at the beginning, but now give it 27%. And it's like, yeah. And the reason is because the 27% isn't conjured out of thin air. It's reallocated from the previous 20% hybrid kind of Eric Smith version. So I was like, okay. That's okay-ish. And then I'm asking these questions about HCN. Why is it core to the network? Did Sutherland think it started with an impact? And then I'm like, hey, do you think that life was overdetermined or underdetermined? In other words, imagine 100 possible Earths, and how many of them is life created? I think this is a good question because you can do this for history and you can do it for life as well, where you say, if you run the tape back a bunch of times, how many times does this thing happen? And so you can ask this for something like the French Revolution, where you say, hey, in 100 different worlds, how many of those worlds does the French Revolution occur in? And you don't really get that when you just ask it to add up causality percentages to 100. And so you can see that here. They say, hey, life probably occurs in 70% of copies or whatever, because you have these things that occur. You get the UV light coming in, providing energy. You get these key feedstocks of HCN and what have you. You don't have these sterilizing events which kill the thing. You eventually get some kind of self-maintaining network, based off these, Smithian style reverse Krebs cycle things. And so if you combine the probabilities, you get 46%, but numbers 2 through 4 aren't independent. And so you can kind of say, yeah, it's roughly in 70% of Earths, you get something like life, which I think is interesting. I think that's roughly correct, that there are a lot of things organic molecule-wise that want life to start on Earth. And it started pretty quickly, all things considered. And then as a side note, by the way, I went over here and I said, wait a second, for so many of these scientific things, Chinese scientists are doing such a great job of, there's so much human capital over there, there's so much STEM human capital over there, so much, chemistry, etc. What have they been thinking about this? And so, then it thought for 3 minutes over here and it said, hey, here's all these great papers in the last, 5 or 10 years about prebiotic chemistry and deep earth scenarios and protocells and systems and network chemistry and computational approaches. And here's how they all fit together. And I was like, okay, cool. Do these Chinese labs, does that update the percentages that you gave from before? I was like, here's this thing. Before I was like, oh, I'm only talking about Nick Lane. I'm only talking about Eric Smith. I'm only talking about Morowitz and Sutherland and whatever. It's like, those are all US, UK guys. Is there actually real research, or is there different research happening in China that is different? Unfortunately, no is the answer. That most these things slightly update the Chinese data to say, okay, maybe slightly different on each of these axes, but not much. All things considered, there's nothing super new happening over here. Again, this is after thinking for a minute. There's nothing super new happening in the Chinese world. They haven't proven anything that the West isn't already working on. So then as a final question, I was like, okay, aren't your probabilities of sulfidic networks, metabolism first, RNA World, hot springs, aren't they just different parts of the process? I'm like, hey, I think it's weird to give 17% to RNA World when that's clearly after developing these feedstocks of carbon chains. So the idea here is that in order to create something like the RNA World, RNA is a very complicated molecule that it has 50 atoms in it or whatever, versus some of these early carbon chains have 3 atoms or up to 10 atoms, but they're very small. And so it's like, I was pushing the AI to say, you're giving all this percentage weight to the RNA World versus metabolism first or whatever, but they're kind of saying 2 different things. One of them RNA World just comes after some of these proto-metabolic systems. And so, yeah, that's what he says. It's like, yep, they're in a chain. The way to actually think about it is that you have to have some of this feedstock generation that much later turns into an RNA World kind of a thing. And then you start to get some compartmentalization and eventually heredity later. And so, yeah, they say the 17% I gave the RNA World earlier is roughly the marginal probability that RNA ends up as the first genetic polymer, regardless of which earlier feedstock or metabolism route wins. Likewise, the 22% for alkaline vents was the chance that they supply stage B and perhaps C, not a statement that the vents exclude RNA later. So I'm not totally, I think these numbers are wrong, but I think that they're getting at a directionally correct thing, which is genetic polymers happen later after the metabolic feedstocks. And so you can see, I do roughly agree with this. This is a better way to say it, which is that when you think about early carbon networks, it's about half-half, maybe they were created in these UV sulfidic lake chemistry, maybe an impact crater, maybe a hot springs hypothesis, and you get a robust carbon network there. Or maybe, the other half is maybe that these alkaline hydrothermal vents created these robust carbon network stocks. And then once you get that, later, whichever carbon network wins, who cares? It's almost certainly, 70% plus that some kind of RNA-like polymer becomes the first genetic system, some kind of RNA World. So I think that is a good way to think about it. The final thing that I asked is, I was like, wait a second, I chatted with Bruce Damer he's kind of a hot springs hypothesis guy, chatted with him a few years ago about this. And back then he said that, I was like, hey, how many people are actually thinking about hot springs versus these vents? And he said something there. He's like, hey, 50% of the papers are wet dry cycling, are kind of like his research. And then 90% of the papers are on land, like no one's in the water anymore. And I was like, wait a second, is that true? And no is the answer. Sorry, Bruce. But if you do quick keyword counts and bibliometric studies, it's more like 10% of papers are doing wet dry cycling and 50% are doing land-based scenarios and 50% still in the water. So it's like, no, when he was saying almost everything is doing these wet dry cycling on land, it's like, no, not that many people are doing wet dry cycling, and only half the people are in water and half the people are on land. I hope this gives you a good idea of how I've been using O3 as a tutor and also as a way to kind of synthesize and quantify the scientific consensus around a given topic, like the origin of life. Thank you, as always, for watching, and thank you to Roots donors for supporting this channel. If you want to understand more about the past and how we got here, check out the previous videos here. And if you want to understand the future and where we're going, feel free to subscribe here. Hope to see you then. Bye.